So sometimes you will see GCF, and that means greatest common factor. So let's go ahead and do 36 first, okay? We always start up with what factor pair first? 1 and? 36. Okay, and when I say factor pair, I just mean two factors that go together. All right, what number comes after 1? 2. So I'm checking. Can I multiply 2 by a number to get 36? Yes. 2 times what? 18. You finished your test? Okay. 2 times what? 18. 18. If I'm not sure, can I go divide 36 by 2? Yes. Sure. All right, what about 3? Is 3 a factor of 36? Yes. Here's a hint. If I add the sum of the digits up, what do I get? Meaning I take 3 and 6, I add it together, what do I get? 9. Is that divisible by 3? Yes. So it has to be a factor. 3 times what? 12. Good. What about 4? 9. Good. What about 5? No. What about 6? Yes, 6 times what? 6. Good. What about 7? What do y'all think? No. What about 8? What y'all thinking? No. 8, 16, 24, 32, 40. Did I land on 36? Nope. What about 9? Yes. But what do you notice? We already did it. So we are good to go on 36. Now what number do we have left? All right, 48. We start with what number? 1. What number comes next? 2. Oh, wait, 1 times what? 48. What about 2? 24. Okay. If I don't know if 3 is a factor, someone raise their hand, how can I determine it? Because usually y'all are good with 1s, 2s, even bigger numbers, but 3s are tricky. Grace, how am I going to determine it? I could do 48 divided by 3. Let's check it out. How many groups of 3 can I make with 4? 1. What's 3 times 1?
3.
I subtract, I get 1, and I bring down my 8. How many groups of 3 can I make with 18? So this tells me, do I have any more remaining? Nope. So 3 times what gives me 48? Good. What about 4? 12. And if I do long division, can I determine that? Sure. What about 5? Nope. Not. It doesn't end in a 0 or 5. What about 6? 8. Good. What about 7? What do y'all think? What about 8? But we already have it. Okay. We're going too fast? So far, so good? Okay. Does everyone have this written down? All right. Did I answer the question just yet? Nope. One way to help is I'm going to circle all of the common factors first and write it. So let's start with 36. Do you see 1 on both sides?
Yes.
Highlight, circle it, start making a list. I'll start with 1. Do I see 2 on both sides?
Yes.
Circle it, write it down. Do I see 3 on both sides?
Yes.
Circle it. And do what else?
Write
it down. Do I see 4 on both sides?
Yes.
Circle it. Write it down. Do I see 6 on both sides?
Yes.
Do I see 36 on both sides?
No.
Scratch it out. Do I see 18 on both sides?
No.
Scratch it out. Do I see 12 on both sides?
Yes.
Circle it. Write it down. Do I see 9 on both sides?
Yes.
No, I don't. And then I already repeated 6. Once I run out of numbers for 36, can I share any more factors? No, because I don't have enough numbers on one of my lists. Now, can I clearly see which is the greatest, the biggest factor 36 and 48 share? What number?
12.
12. So I'm going to, as my final answer, and I can abbreviate it with GCF, 12, and I box it in. So that way my answer is clear. Box it in. It is kind of a lot of work, but it's not hard. I know y'all are all capable of doing this. Just don't skip those steps because it's super easy. All day, students were accidentally picking a common factor, but they weren't picking the biggest one, and they got the problem wrong. So just be careful, okay? Questions about this? Okay, let's go ahead and look at the next problem. Go to problem number 4. Yep, where you see the N and R. Yep, right there. It's not clicking? It does this every now and then. It'll just... But it's not... For some reason, it's... Yeah, I know. Okay, well, I'm going to figure this out while y'all work on it. Okay, look at problem number 4. For A, it says, what is the greatest number? Go ahead and highlight greatest number. Anytime you see, like, what is the greatest amount that both can share, or you see the word greatest and it's talking about splitting things, you're always going to find the greatest common factor. And that's going to be important to know because in a few days, we're going to do least common multiple. So you have to understand the difference. So if I'm ever finding the greatest, something can fit into both, it's common factors, okay? That's just a hint. So make sure you highlight the word greatest, circle it, and you put GCF. So you remember when you're finding something that is the greatest you can split it into, it's greatest common factor. All right. Right now, you are doing 4, A and B. Oh, now it's working. With a partner. You may pick a partner. I'm giving you 4 minutes. If you finish early, complete 3. So if you finish early, go ahead and complete 3. Look, press countdown timer. Top right. Oh, but in the blue. I mean the red. There you go.
Good job,
Oh, it's already on 4. All right. Wait, pause it for a second. Let them sit. 5, 4, 3. Oh, still, yeah, just move the bag. 2, 1. By now, you are reading the problem and you are beginning. 4 minutes, go. No calculators the rest of for a long time.
7.
For 14, don't overthink it. You should know the factors of 14. There's not many. Because think about this. Everyone stop and pause. Okay, for 14, don't spend too much time. Think about this. You know 5 is 5 a factor of 14. Is 6 a factor of 14? You should know quickly. Is 9 going to be a factor of 14? No, because 9 isn't that far from 14. So don't spend too much time writing these factors. All right, 2 minutes. You should be almost finished with 4A by now.
Okay, so 4 is the last time we're going to do
And then I see
14. Alright, you have less than a minute. Yes, Asher. You're done? Okay, go ahead and work on problem number 3. Yep, problem number 3. Alright, what's your greatest common factor? Or how many notebooks? Good, so make sure you write that down. It's canned. Once you hear that noise, you're good. Yep.
She couldn't reach it. Make sure you talk about 3 times. Talk about 3 times.
Alright, 1 more minute. Okay, you should be finished with 4A. Where's your other factor? I see a bigger number than 7. There's all your factors. There's a lot more here, and there's more here, and you're doing 4A and B. Good. There are 14. I have 28.
It's okay. Wait, it's 7. Wait, 7.
Right, and I'm only having 14 back. How many don't do that? Not one. Wait, sorry. No, when you hit the think about 14, what number gave times 2, so that means what? I take 28 and I split it up into 14. How many goes back? If you hear my voice, clap once. If you hear my voice, clap twice. If you hear my voice, clap 3 times. All right, go back to your seats in 5, 4, 3, 2, 1. Number 4. We don't have a 21, right? Oh, we do? Oh, who's 21? Oh, that's who I called first. Okay, go. How many gift bags, identical gift bags, can Riley make? Good, 14 identical bags. I saw quite a few put 7, but is that the greatest number they share? No. It's less than 14. Awesome. Go get a ticket, Jackson. And you can get a ticket too, Braylee, for saying that. All right. Oh, look, there's some right here if y'all need to split it. off. Okay, cool. So I was finding numbers that I can split 28 and 14 into. How many pins, number 4, does each gift bag have? Who's number 4?
Trey.
All right. Number 13? Who's number 13?
Me.
All right, go ahead, Allie. How many pins? Okay, but I think you can get to it. So use what you know. You know you have how many bags?
14.
And how many total pins?
28.
So how, if I have 28 pins and I'm splitting it into 14 bags, how many go in each bag? 2. Did anyone use the factor pair of 14 times 2 equals 28? Did anyone use that? Did anyone divide 28 by 2 to get 28 divided by 14 to get 2? Did you get the same answer? So either way works. 2 pins. Good, go get a ticket. In number 18, how many notepads? Okay, you can get to it though. How many notepads go in each bag? How many bags do you have? How many bags do you have? $14. And how many notepads do you have? So you have 1. Good. There you go. Go get a ticket. 1 notepad. You could look at your factors pairs to see 14 times what gives me 14. Or could you divide? Either way works. All right. Any questions about this? So far, so good? Okay. So can it just wait for a second? Make sure you change it to returning. Okay, listen up. This is one strategy we can use to find factors by listing them out. Raise your hand if that's what you did. You listed all your factors and you found which ones are the same. That is one strategy. I'm going to show you one more strategy that we can use, okay? Remember, do you have to use a specific one?
No.
Do whatever one your brain prefers. Okay. Go ahead and look at problem number 5. Problem number 5. Here, I'll sit on right here. I'll do it. Okay. We can find greatest common factors by doing prime factorizations. So let's break this down. What is a prime number? Does anyone know? You can't do a prime factorization if you don't know a prime number. What does a prime number mean, Colt?
It's like only divisible by 1.
Good. 1 and itself. It only has factors of 1 and itself. Go get a ticket. That is what a prime number is. Okay, so you are writing this down because you can't take notes if you're not writing your notes down. A prime factorization is just numbers, prime numbers, prime numbers written, or sorry, no, we'll just put, it's fine. We'll take off the word prime. Numbers written as a product of prime numbers, okay? That is what a prime factorization means. Numbers written as a product of prime numbers. What does this mean? I'm going to show you, okay? When you have this written down, put your pencil down. Okay, so far so good? All right, so what does this look like? Basically, a prime factorization is when I take the factors of a number, but they only are prime numbers. So I only can pick factors that are prime. And I put them all together in a multiplication sentence. So let's look at 36. Someone give me a product of factor pair, meaning give me two factors that when I multiply them together, I get 36. What two numbers? Anyone, just spit them out.
6 and 6.
All right, 6 and 6. To find the prime factors, we are going to do something called a factor tree. Has anyone heard of a factor tree before? Cool, a few? Okay. What a factor tree is I take 36 and I break it into only prime numbers. So let's start with 6 times 6. Is 6 a prime number? No. So I have to keep going. Can I find more factors of 6? What two numbers?
3.
Is 3 a prime number? Can I only multiply 3 by 1 and itself? Yep, so I circle it. A good trick is just to memorize that 3 is a prime number. Is 2 going to be a prime number? Yes, because the only two numbers I can multiply to get 2 is 1 and 2. Do I have any more numbers on this side that are not prime? No, I'm done. Can I break this down to even smaller numbers?
No.
So once I'm done, I move on to the next side. Okay? Well, this is easy because did we just do the same number?
Yeah.
So 3 and
2.
all right, circle it. You're only circling your prime numbers so you know you're done. That's how you know you're finished. Now I put this all together in a multiplication sentence. That is the prime factorization. Does order matter for multiplication? No, it does not. Is 5 times 3? What is 5 times 3? What's 3 times 5?
15.
So regardless of the order, does it matter? Am I going to get a different answer? I personally like to write my smallest numbers first, though. So what's the smallest number you see? 2. And I see how many?
2.
So remember, this is multiplication. So I'm doing 2 times 2. Oops, let me make it smaller. And what I like to do is I cross it out so I know I'm done. What other numbers do I have left?
3.
And how many do I have? Times 3 times 3. Cross it out. That is a prime factorization. It's written as a product of prime numbers. And I can check my work. What is 2 times 2?
4.
What is 4 times 3?
12.
What is 12 times 3? So does my final answer give me 36?
Yes.
Yes. Okay. Are there other factors of 36? What's another set of factors? Anyone?
2 and 18.
2 and 18. Okay. If I broke down 36 by using 2 and 18, I'm still going to get the same answer. I'm still going to get 2 times 2 times 3 times 3. Here's my 2. Give me 2 factors of 18.
6 and 3.
All right. Is 3 a prime number?
Yes. No. Oh, I think you said 3.
No, I did. Is 3 a prime number?
Yes.
It's only 1 times 3. Everyone, you need to memorize. 3 is a prime number. Guess 2 is a prime number. Those are very common. All right. I have 6 left. What are the factors of 6? 3 and 2. Good. Circle it. Did I get the same exact thing as this one? Do I have 2 2s right here? Do I have 2 3s? So regardless of what factors, am I going to end up with the same answer? Yes. You only have one set of prime factorizations for every number. Okay, it's always going to be the same. So, question so far? Okay. Y'all are probably wondering, what does this have to do with greatest common factor? We can use these prime factorizations to find the greatest common factor. So if we looked at 48, let's go to 48. Problem number 6. Stay with me so far. You will see in just a minute. All right, yep, you can move it to 48. Oh, it's not working again. I don't know why it's doing that. I don't know. All right, let's do 48's factor tree. So remember, if I am doing the prime factorization of a number, my factors can only be what kind of numbers? Prime. In a prime factorization, your factors can only be what kind of numbers? Prime. It's in the sentence. All right, give me 2 factors
2 and 24.
of 48.
2 and 24.
2 and 24. Good. I'm on the wrong one. All right. Is 2...
5.
Oh, you're right. Here we go. Is 2 a prime number?
Yes.
Yes. Is 48 a prime number?
48.
Do you think it's going to have multiple factors? Oh, I'm sorry. 2 and what?
24.
24. Okay, come on. Put it down. Is 24 a prime number?
No.
No. What are 2 factors of 24? 6 and 4. What else? 12 and 2. Do either one work? You'll get the same answer. All right. We keep going. Do you want to go to 6 first, or do you want to go to 4?
4.
All right, let's do 4. What are 2 factors of 4?
2 and 2.
Is 2 a prime number?
Yes.
Yes. Circle it. All right. What do we have left? What number is not circled? 6. So I'm not done. I have to do 6 as well. What are 2 factors of 6?
3 and 2.
3 and 2. Are these prime numbers?
Yes, ma'am.
All right. Do I have any more numbers left that are not prime? So I am done. All right. How many 2's do you see? 4. Cross it out when you're done. 2 times 2 times 2. And then what's left?
3.
Good. Can I check my work? If I were to multiply this out, I would get 48. Okay. So now we have found the prime factorization of 36 and 48. Are y'all with me?
Yes, ma'am.
Stop with the conversations. Whoever is talking, enough. Okay. So this is how we can find greatest common factor as another strategy. If this is not on your... I don't know why it's only letting me... All right, this part is not on your paper. Well, it's kind of on your paper, but it's not in all one place. So right now, I would write this down. On the side. These are the 2 prime factorizations that we just found. The first one is 36, and the second one is what number? Okay? We just did it. It's just all in one space. Okay, so this is how we can find the greatest common factor. The first thing we have to do is find common pairs. What does a pair mean? How many is in a pair? 2, right? If you have a pair of shoes, how many shoes do you have? 2. If you have a pair of socks, how many you have? 2. So I'm going to find a common number between 36 and 48 that I can make a pair with. So for example, I see 1, 2 here. Do I see a 2 for 48?
Yes.
That is one pair. Circle it. What number did I just make a pair with?
2.
So I write it at the bottom. But I'm just writing one number from each pair. I'm not writing 2 twice because I only made how many pairs? 1. Can I make another pair?
Yes.
Yes. Of what number?
2.
So I'm writing at the bottom what number again?
2.
Remember, it's per pair. I'm not writing 4 2s down. I only have how many pairs? So I write 2 of them down. All right. Well, I have a 2 down here, but does 36 have another 2?
No.
So can I make a pair?
No.
Scratch it out. I have another 2, but can I make a pair?
No.
No, because it has to be 1 from each number. Can I make any more pairs?
Yes.
What number?
3.
How many pairs can I make?
1.
So at the bottom, I'm writing what number?
3.
All right. Now I have made a multiplication sentence of all of my common pairs. What is 2 times 2?
4.
What is 4 times 3?
12.
So the greatest common factor of 36 and 48 is 12. Another strategy that we can do is we can find the prime factorization of both numbers and multiply their common pairs. Okay? That is just one strategy. If you don't like this strategy, do you have to do it? No. But what we did is we wrote, so I would write this down. You find the prime factorization of both numbers, and then you multiply all of the, and I like to say common pairs. When I mean common pairs, you multiply the numbers that you made a pair with. So we made 2 pairs of 2 and 1 pair of 3. Okay? That is how we can use the prime factorization to find the greatest common factor. Okay? Right now, everyone go to their exit ticket. Go ahead and circle 1, 2, and 3. For problem number 3, you don't have to explain it. Remember, if it says prime factorization, what are the only factors that can be in that sentence? Prime numbers. If you have numbers that are not prime in your factorization, is it correct?
No.
All right. Look at your notes if you need help. Go ahead, work on your group with your group on this. That's what I'm trying to